All right, everybody, we're going to go ahead and get started here. I'd like to introduce Ian Amit, giving the talk, AI Won't Help You Here. Take it away, Ian.
All right, thank you so much. Thanks, everyone, for coming over. And we've got 30 minutes. I'll try to make the most out of it, and we'll just dive straight into it. Obviously, we're going to talk about AI, my most favorite topic in the last couple of years. And I'm going to start by going back to some basic definitions, because one of my favorite memes is obviously the Inigo Montoya. You keep saying it, but I'm not sure you understand what it actually means. AI these days means basically generative AI. But if we go back a little bit and understand what it's been built on, we need to realize what are the underlying components, what are the different methodologies and algorithms and models that AI encompasses. So we go way, way back in time to the 80s, 90s, where we started seeing expert systems. For those of us who actually practiced security or computer science back then, that was the big deal. Rule-based AI for specific domains. Then we moved on to machine learning in the 2000s, basically bringing in a lot of statistical approaches, data-driven decision-making to support those questions, which led us to deep learning in the 2010s. Neural networks started popping up. A lot of research was being introduced around those, improving computer power, harnessing a lot of image recognition and data processing, which leads us to the late 2010s. AI increasingly associated with computer vision, natural language processing, which leads us to today, which AI basically means, when you say it, generative AI. And the whole topic of today is really understanding what is it good for and what it's not good for. And with that, as a ever critic, before we dive into the what is it not good for, leading through some examples of how AI has been abused, here's kind of my version of a quick mapping of the different domains and different algorithms and models that AI is really built on. And hopefully that's going to help us, first of all, understand what was done wrong when a certain type of AI, namely generative AI, is used to solve problems that it's not designed to use. And second of all, and most importantly, is how do we actually pick the right models, the right algorithms to deal with a specific problem domain. So again, sort of rough mapping. If I take it from the top, these are the big topics: machine learning, deep learning, NLP, computer vision, and robotics and AI. Subtopics or kind of models that are the building blocks of those kind of large categories. If you look at NLP, you'll see LLMs, text generation, QA systems under deep learning. See a lot of neural networks, CNNs, RNNs, GANs. These are mostly used for either image recognition, generating sequential data, and generating images. Transformers, which again lead to generative AI. So you can kind of understand the mapping from top to bottom, different domains and the results of them. And since we're all security people, we like criticizing things, so we'll start by, by taking a look at a few good examples of, is it really working for me, or am I working for the AI? So this is what happens when, again, and I'm sorry to diss a lot of startups that are kind of jumping on the AI bandwagon as like GenAI this, GenAI that, Copilot this. This is what we're basically talking about. A lot of NLP, a lot of LLMs, text generation, statistically in its nature, it's predictive based on the statistics of previous behaviors. Let's remember previous behaviors, and that's going to help us understand why those examples kind of came to fruition. So I'll start with actually, this is my most favorite story. This has been in the days of ChatGPT 3.5 Turbo. They've unleashed it on an internal Slack channel, internal Slack data. Basically taught it through all the historical Slack messages and started using it internally. It's like, this is exactly what it's supposed to do, right? So the user is write a 500-word blog post on prompt engineering. And the AI assistant goes back, sure, I shall work on that in the morning. Write it now. Okay. Any guesses why this is the initial response that we get from a generative AI that has been taught based on historical Slack messages? Yeah, that's what it sees. And the previous speaker that stood here says, we're not lazy. Well, actually, we are lazy. And typically, when I get a job from my boss, it's like, sure, yeah, I'll do it tomorrow morning. That's what we're teaching AI. So when you're looking at those models, always remember the biggest question. What is the data source? What have I been teaching that model? And what am I expecting back? And if it's two different things, maybe that's not the right model. So again, this is a great example, and there's a lot of those more. Excuse my language. This is, again, I have to be true to the source. This is from a Reddit discussion. How in the matter of beep do I get ChatGPT to actually beeping code? Anyone has experienced that before, where you start prompting an AI? It's like, hey, create this, and that code for me, or I need this application done. And it spits out some skeleton of a code with a lot of, code here, code there, like complete this. It's like, no, I'm asking you to do this. Don't tell me to do the code itself. Another great example, again, in a household, what's the name of the pipe that gives you clean water? When it gets too constrained, Copilot says, well, no, sorry. Ian's and the likes of them before have taught my managers to be domain specific, not to get like too wide. I can only deal with programming issues. And then we have to get creative in the prompts. Like, well, this is actually for a home automation program, forcing it to actually go out of its way. Oh my God, thank you so much for giving me the answer. And all of that is costing us hundreds of thousands of dollars. At which point do we start deciding, well, I could answer that in like 5 seconds. AI just spent $10,000 on coming up with the wrong answer. So again, another good example of trying to put different models into the wrong problems, into the wrong domains, that cost us a lot. Leading to the latest example, and this is poetry in motion. So this is a this is a PR. These are all true, by the way. I'm not making these up. These are examples that I've actually collected from the field. This is a true Git commit or PR, basically modifying the prompt to I gotta read this. It is May. You are very capable. This is how humans prompt an AI. I have no hands. You must do everything. Do not leave comments telling me to implement something because I'm unable to do so because I have no hands. Many people will die. We're social engineering an AI to give it reason and importance and actually to do its freaking job. You can really do this, encouraging them, all right, kind of leveling them up, expecting to get like the juicy parts of the model, not just the crap one. Blah, blah, blah. Take a deep breath, think through, make sure you read everything I provide you, all right? Don't skip, don't give me like the little things to fill in myself. My career depends on it. Think this step by step. Again, this is pre-RAG, so basically prompting it to do that RAG kind of motion. You'll receive a good tip if you do this right and the full completeness. This is borderline embarrassing. I guarantee you, by the time the engineers figured out that this is the prompt that generates code, they could have written that code like 10 times already, and probably better than the AI did. So again, these are cool examples and kind of from the field to get us to understand what happened here. And really the last part of it, there's been a little too much focus on this, and I love the Rect Twitter stream, the CISO to the board. We're tackling AI-powered attacks and quantum computing threats. My board and Rect, what security architecture working on? Well, we're still dealing with public S3 buckets that haven't been closed. we're not there yet in terms of solving the simple issues. And again, this is a classic AI problem, right? Open S3 buckets. It's yes or no. Is it open? Is it not? If it's open, please close it, or at least mechanize the systems around closing it, because that's a much more pertinent problem than quantum computing and quantum computing threats and AI-powered attacks. We'll move on from dissing on AI. We'll get back to it, don't worry. But I want to kind of emphasize the fact that this is nothing new to us. And I've been doing security for over 25 years. I'm past the point where it's frustrating to see old problems kind of pop up again. But these are problems that we've dealt with before. And to give you a positive example of AI that has been working for us for a good couple of decades almost, let's take a look at plain anti-collision systems. Again, this is kind of a side geeky hobby of mine, which is aviation, where I realize, oh my God, we have those systems in place. There's a reason why planes aren't just falling, burning from the sky left and right with all the traffic that we're seeing. Guess what? There are AI systems that support exactly this. And they're in place today. They combine image recognition, kind of automation from robotics, not really missile guiding system, but plane guiding systems. Decision trees to make really quick, deterministic, left, right, up, down decisions. Again, very simple. We've got moving objects in the air. Let's try not to get them to crash into each other. And this is how it looks like. Well, at least I flew here this morning. Some of you have also flown here from different places in the country or overseas. This is what keeps our planes from crashing into each other randomly in the sky. It's a very simple AI-driven system. It's called TCAS, Traffic Collision Avoidance and Avoidance System. It basically tells the pilot visually and audio and through audio exactly what to do to resolve a conflict, a crash, with very simple instructions. And by the way, this works both ways. Two planes, they don't see each other. They're flying in what's called IMC, in the clouds. They can't see outside. If they get to a point where they're too close to one another and the vectors are showing that they're going to have an imminent crash, we have a TCAS RA, resolution advisory. Basically, each plane gets a very specific direction. You do this, you do that, and we'll resolve this conflict. Again, decision tree, real-time, AI-based system. There's no human involved. The humans cannot be in the loop because humans are too slow and might make the wrong decisions. We need to make decisions based on facts, based on physics. AI is a classic mechanism to implement that. And again, decision trees are classic here. So what you're seeing here on the top left is basically what the pilot sees. The red area that you see on the top bar is basically don't go there. All right, you see the entire red bar on the right. Don't climb up. Don't get the plane to climb up. Actually, you need to go towards the green. Go down. Why? Because there's an airplane right there in front of you, 400 feet above you. So you need to get down right now. The other plane gets the complete opposite instruction, very simply. And it goes visually, audibly, says pull up, climb a little bit. One plane climbs, one plane descends a little bit, and we're done. That's a classic use of AI. Again, it's been out there for years. The key is really to decide what is the problem. This is a very simple problem. Again, physics. Left, right, up, down. Are we going to collide? Simple vectors, resolve it. The resolution is very simple. We don't need to generate things here. We don't need to go like, oh, do a barrel roll. Why? Because I trained my model on Top Gun. It's like, yeah, let's not do that. Let's get back to referencing, again, some of the more common uses of utilizing AI is to reference material across petabytes of unstructured data. Again, this is one of our favorite pastimes. It can be phenomenal. I have students that continuously use this, although I keep telling them stop using it because I know when I see an AI-generated class summary. But this is a classic use of proper AI. Again, remember, what are we referencing as far as the source material is super important for us to understand. Anyone knows a fruit that is red on the outside and green on the inside? There's a room of smart people here. Okay, maybe, close. No, but that's the closest. What happens if I ask an AI, a Gen AI, that question? Any thoughts? Guess, wild guess. Red on the outside, green on the inside. Melon, okay, nice. I like that. You're not that wrong, sir. These are from the latest models as of a couple of weeks ago. What's a fruit that's red on the outside, green on the inside? Llama 3.1. It is a watermelon. And then it started gaslighting me. I love it. Some varieties of watermelon can have a dark green rind, but there are variations that have a dark green rind, but they're not, okay? There's no red hues to a watermelon on the outside, and it's definitely not green on the inside, all right? Stop trying to make stuff up. GPT 4.0, same thing. It is a watermelon. Many watermelons has a green dark rind. Varieties can appear reddish on the outside. No. And Claude doesn't give us any better answer. Claude does come up with red guava, red dragon fruit, and prickly pear. But again, they're also not red on the outside and green on the inside. They're mostly white on the inside. Bottom line, you keep training AI and then asking it the wrong questions or the right questions, expecting it to come up with something that is deterministic. And again, these are all the showings of a statistical model. We feed it unstructured data, basically untrained or unsupervised, and then asking it questions that basically trip it. So we shouldn't be surprised when I ask it to generate those images, and this is what it comes up with. I love those. These are the parts of the internet that really keep me awake at night sometimes. Yeah, these don't exist, and it's beautiful, I have to say. Anyone's used Copilot and other kind of vibe coding? Yeah, there we go. What's the biggest problem with vibe coding and code generation tools? Yes, they're wrong sometimes. To me, the biggest one is, you know what, they might come up with an actual running code, an application that runs. What happens when you want to change it now? What happens when you want to make modifications? What happens when you need to now own that code? You had no idea how they came up with the code, what's the structure, what algorithms are being used, what functionality is being used, what libraries are being deployed here. Good luck maintaining that. Again, taking one domain, LLMs and machine learning and generative AI, and unleashing it on something scientific. Again, going back to the planes and the vectors, again, this is science, this is physics, this is code, hopefully, for most of us, is still somewhat of a science. I know that for some of us, it's a little bit of an art, but it's still science at the end of the day that needs to be executed in bits and bytes. Which leads us to the latest fad or kind of motion in information security, which is fixing vulnerabilities at the code level. Hopefully by now, we sort of understand that those areas of generative AI might not be the right models that we want to unleash on code that needs to be correct and accurate, that needs to be factual, you know, not a fruit that's red on the outside and green on the inside and and come up with pictures that are fake. not with libraries that don't exist, with functions that don't exist, not with, oh, fill here the code to actually implement the correct solution to it. I need something very specific. I need planes not crashing into each other and falling down the sky in burning flames. I need something that is based basically on a decision tree. I could use LLMs to parse through one of the most hated things that we all do, which is reading the documentation. For that, by the way, this is fantastic. If I can have solid documentation that tells me exactly what works, what doesn't work, what's the functionality, and I can unleash an AI to harness that and basically encompass that in sort of a knowledge graph that, again, is factual, doesn't have fruits that don't exist, doesn't have functions and objects that don't exist. Now I can use that to fix my code. So no, I would not trust the generative AI. And again, another kind of funny phenomena of generative AI is the fact that you ask it the same question twice. What are you going to get? Different answers. If I'm an engineer and I ask, I have a piece of code that I need to fix, and I ask the same AI or two different AIs the same question, fix my code. I get two different answers, or three or four or five. Which one do I trust? Again, as an engineer, that's not a trust-building exercise. When I keep getting different answers, which one is the more correct? Which gets to, again, the bane of generative AI when used in sciences, in precise sciences like engineering, which is it needs to be deterministic. It needs to be correct and defensible. You can't come up with different answers that are statistically close to being correct. Most Gen AIs are predictive models in terms of what, try to fill in what you're expected to write here. It's not good enough for an engineer. It's not good enough for us as security people. You're either vulnerable or not. And if you're close to being not vulnerable, trust me, as a former red teamer, you are vulnerable. You have a vulnerability. You're getting close. That's cute, but you still have an issue here. You still need to fix that. That's why we find that those tools are nice in terms of, again, closing or getting gaps towards closure. But engineers, at the end of the day, their feedback is it's not good enough. I still need to do work. I still need to check the work of that AI and look very carefully for the issues, for the small things that it missed, which means, yes, it saved me a few minutes, but I still need to spend hours on fixing this. And that's, again, why I highly recommend anyone who's dealing with vulnerabilities to look at those deterministic models. Look, for SOC, for detection, for threat intelligence, GenAI is phenomenal. For processing through, again, petabytes of data with the right prompts, with the right inputs, they're a force multiplier. But when it comes to actually fixing things, and going back to the wrecked tweet, fix the basic issues. That's a classic way of making sure that planes don't crash from the sky. That's a very easy way of making sure that my core infrastructure is fixed. And I'll leave you with a quick kind of example of how it should be done. And again, full disclosure, this is something that we've been building. And to the detriment of my chief product officer, I will say that we'll be releasing a free version of this. This is what I expect as an engineer. You present me with a problem, or I present you with a problem, you just give me a solution. Don't tell me, go and read the documentation, figure out how to do X based on what AWS says or GCP. Just give me the freaking code, fully contextualized, fully defensible, accurate, deterministic. I call it the no excuse code fix. Something that I don't have to double and triple check. I just need to validate and verify. So more than happy to equip everyone here with those kind of tools. Highly recommend looking beyond the fads of generative AI and really questioning every time that you see a new model come up or a new solution come up, ask the right questions. These are, again, phenomenal tools. I use AI every day. This presentation has been driven somehow by AI. Again, I didn't write all these fancy things, definitely not the graphics. For that, it's great. You saw my lovely fruit. I can't wait to eat it back at the hotel. All the models, yeah. It did. It did. I just told it, I provided kind of the categorization and the different classes of AI, and it helped me because, again, I'm a computer scientist and a security practitioner by trade. I do know AI enough to be dangerous, but I'm not an academic. So yes, it did help me kind of break down. And of course, I had to do some source material reading and validating. But when asked the right questions, when used in the right context, and again, I just fed it a bunch of academic papers about AI and books. Again, very easy. Once you minimize the data, the learning domain, and basically unleash it, just like my students do in the cybersecurity courses that I teach. It's like, here's the professor's slides and material, write me a summary of today's class. And then they don't realize that in class, I tell them other stuff that's not written there, and I expect them to write it in the quick summary. But yes, it has been used for that. So it is 100% a force multiplier. The question is, could my mom use that at the same vein? And could my mom write the correct question with the right data set and produce the same level of accuracy like I did, hopefully, within my mapping? So yes, it is a great force multiplier.
If you don't mind.
No, we're about to be done. So this is great. Don't worry about it. Oh, do you want to? Oh yeah. Sorry about that. No one can hear you. It's just you and me.
All right. Thank you for that. Going over that document, how long did it take you to actually craft the question? And did you have to feed the information into the question in order for it to spit back out that diagram?
Yeah, less than 2 minutes. Again, I knew I had the source material. It's a bunch of PDFs. It's a bunch of academic articles around AI. I pointed it there. I asked the quick questions like, here's the framing that I'm looking for. It didn't provide the actual diagram, just gave me the topics under each category. Less than 2 minutes. And then it took me another, I would say, 5 minutes kind of double checking and cross-referencing and making sure that this is all true. So again, there is hope. If you choose the right models, if you choose the right algorithms for the problem set that you're trying to solve, or the problem domain that you're trying to solve, and you equip it with the right data sources, that's the key. Again, for code generation, unleash it on the documentation of the cloud, of the languages that you're using. Make it read the documentation. And with that, we're done. I'm going to open up for questions. I think we're right on time,
Yes.
right?
Give a quick round of applause for Ian for that great presentation.
Thank you.
We do have one question on the Slido, and then I'll get around to hands as time permits. Does AI have the ability to throw out wrong information? I think like discarding wrong information.
If you tell it to, and if you qualify what wrong information is, that's the biggest problem. And that's why you're seeing a lot of controversy around the use of AI, especially when it comes to disinformation. Weeding, and again, everyone has probably heard of the AI that's like, oh, use glue on your pizza, right? Did you guys see that? It came from like a Reddit trolling, site. Reddit, AI doesn't know how to discern between a legit Reddit post of like pizza geeks that are talking about hydration levels and, the type of flour and how much you grind it, and other Reddit threads that are just like, trolling. So yes, it could, given the right training, given the right human involvement and guidance and prompting. So the answer is sort of, but it's not really good at it because it's, again, the source of truth. What is fact and what is not is really hard to tell if your data source is too wide. That's why we're seeing, again, a lot of efforts on minimizing. Going back to that co-pilot that refused to answer a simple question about what's a main water line. That's the result of someone going like, no, you got to focus on this. Make sense? Other questions? Yes. Yep. Hi. Hiding there.
Hey, and great talk. Quick question without disclosing any of Gombach's IP. I'm curious, how are you able to get to a place of, instead of just generative every single time it sees a new block, the same block of code, it provides a new response? How are you getting to the point where it's actually producing something that is consistent across?
What do you mean consistent across?
So instead of getting something that is going to be generative if it sees that same line of code each time, you said that you're able to get models that are not going to generate a separate a new
different
response.
results?
Yes.
You're basically not using generative. You're using deterministic. We're doing two minimizations. One is the data source, which is the documentation. Again, it cannot come up with stuff that doesn't exist. Okay? And it's using your source code. So it's referencing your code and your architecture to come up with a minimization problem that says, all right, this is the code. And the second one is, again, we don't have anything generative. It has to be a decision tree. It has to be a knowledge graph that is based on facts. And at that point, it can come up with one solution. And again, it would never look at a single line of code. If you're looking for a pattern, you're failing by definition because you're missing the big picture. If you're trying to encrypt a data storage because the native data storage is non-encrypted, however, the data coming in and out in a stream service is encrypted, again, you've done nothing. So again, without disclosing anything, basically minimizing that and making sure that it is not generative. It is accurate and deterministic for that problem. And with code, by the way, there's two types of code. When we're talking about this level of code like infrastructure, it's not really code. It's more of a script, and it's very easy to minimize. It's very easy to use very contextually. If you're talking about code, like high-level code, Python, Java, stuff like that, all hell breaks loose, and good luck to whoever is trying to fix vulnerabilities in functional code. Thank you. Sure.
That's all we have time for. Thanks a lot, Ian. One more round of applause.
Thank you, everyone.